Hello, this is Duffie Cooley, a solutions engineer for CoreOS. You guys out there? We have voices? Just checking with the questions if you're there. All right, so let's get started. This webinar is kind of talking about some of the tips and tricks that you can do with Kubectl, and it talks directly. I'll be covering a lot of the content that's inside of the blog post that's located at coreos.com/blog/Kubectl tips and tricks. I'm going to start with the bash completion piece and kind of show you some of the power of that bash completion mechanism, and then also talk about how to configure that. So there's actually a link here that takes you to the documentation for Kubectl, and it describes it pretty well. I've actually stolen a little piece. Most of the work that I'm doing, I'm actually doing on a Mac, so I'm kind of expecting that that's probably true for you as well. If it isn't, then I'm sure that there are primitives for like doing this in Linux, and I know, in fact, I know that there are in Linux. I'm sure that there are also in Windows if you're using the Windows Linux integration. But bash completion is the important bit. It doesn't have to be bash; it could be ZSH as well. So in this first part, if you already have bash completion installed, then you can actually just source the Kubectl and then whatever your shell is. So if you do source and then basically take the output of this command, and let's just look at what that would look like. If I just run the command without source, I can see what's actually happening. And effectively what it's doing is creating all of those commands that we're going to use, and then using complete to give it all the different options that show up. And that's effectively what any bash completion solution would allow for. So what that means is that once you have that configured, you can do things like kubectl get logs, logs. Let's see, which cluster am I on right now? Kubectl cluster info. This is a great way to actually answer that question. If anybody's interested, you can actually figure out which cluster you're operating on just by doing cluster info and looking at the IP address. I know that usually if you're switching context back and forth between different clusters, it's sometimes challenging to actually understand which one you're on at any given time. So if you do kubectl get pods all namespaces, you can see that this DNS pod, for example, has multiple containers running. You can see that because we see 3 of 3 running. So once we have bash completion done, we can actually look at the logs of one of those without having to actually know exactly what we're going to type. Kube system, kube DNS. And then I can actually look at the logs for a particular component without having to type in any of that stuff. Just tab complete, and there I see the logs from just that one line, which is kind of the power of the bash completion piece. Saves me a lot of time, and I'm sure that it would save you guys a lot of time as well. The next part I'm going to talk about is basically the difference or the way to address multiple clusters. But first I wanted to see, are there any questions around the Kubectl bash completion or ZSH completion stuff? If you do, just enter them into the question screen and we'll come back to them. The next piece that I'm going to talk about is being able to understand how to switch between different contexts when manipulating different clusters. And so in the example, I actually show a couple of different configurations. And here I have a couple of different configurations already identified. And what these configurations are basically just a file that holds an API object that describes the context for a particular cluster. So in this case, if I do kubectl kubeconfig minikube cluster info, I can see that this is the configuration for this cluster, and I can do things like get node, and using this -- kube config and then the configuration file itself, I can assure myself that this is exactly the cluster that I'm looking at. I can do the same thing for that other configuration I have in the directory, and I can see a different output. This one's remote, so it takes a second longer. But we can see, for example, all the nodes in a cluster that I have stood up in AWS. Now, Kubectl actually provides quite a variety of different ways of actually understanding context. And one of the most powerful ones is this idea of the environment variable kubeconfig. And let's talk about what that actually does. So if I do export kubeconfig equals minikube:/SEDemo, and then my state. Before I do that, I have to actually make state. So I'll make a new file called state.config. And then we'll do our export. Now this is an ordered list of files, and what that means is, and right now you can just tell that I'm assuming that all of those files are in the directory with me. If I were doing this for real, I'd probably want to actually include the directory structure that points to it. Otherwise, as soon as I move out of this directory, I won't be able to see all that stuff. But let's look at what actually just happened to the config view. So my configuration view now includes all of the different clusters. So if I do kubectl context config context, I want to do a get context. If I do this now, because of the export of the kubeconfig, what I've actually done is I've created a merged version of all three of those files in memory, and that's actually the configuration, the context information related to the entire associated with all of those individual files, which is pretty interesting because now what I've got is a way to switch back and forth between these two different clusters. Right? So because I'm actually merging all of them with this command, effectively I'm merging all three of these files in an ordered state into one context that I can actually view and manipulate with the kubectl command. If I were to remove the SEDemo context, right, when I do that same command, I can see that only minikube exists. And this is what I mean by a merge. This allows me to actually merge all of those contexts, all of those individual configuration files that apply to each individual cluster into one file. Now what's interesting is the state file is still completely empty. It has nothing in it. And because it's ordered, what's actually happening is that I'm only sitting against the configuration that's known in minikube. So if I were to do kubectl cluster info again, I can see that my configuration is pointing at my minikube cluster. But at this point, I can also again use kubectl to switch context to that SEDemo configuration. So I would do config use context SEDemo, and this is actually note about it in the output here, right? So I want to use this context by name, the SEDemo context. And now if I do my kubectl cluster info command, I can see that I'm actually addressing the SEDemo cluster. And at this point, my state file actually has content in it. And the only thing that I've actually changed here is what the current context is. So that's one interesting mechanism. And then the other thing that I wanted to show you about context, which is yet another piece that I think a lot of people don't realize with kubectl, is I mean, we find ourselves frequently writing stuff, or typing stuff like kubectl get pods namespace kube system, right? So like any little thing I want to type, I have to type in the namespace. One of the benefits of the context stuff is that you can actually create a different context within the scope of a cluster that is scoped to a specific namespace. And let's kind of talk through how that works. Config get context. So we can see all the contexts that currently exist. We can do kubectl set context or config set context help. And effectively what the three options that it wants me to provide are cluster, namespace, and user, right? And I can see what cluster and namespace and user are here, although it's a little confusing because user is auth.info, but regardless, that's where you get those three variables. So now you can do kubectl set config set context, give it a name. We'll say this is SE demo cube system. We'll give it the namespace cube system. User is going to be SE demo IDC, and cluster is going to be the cluster that we're talking about. I'll hit enter and I can see that I now have a new context. If I do kubectl config get context again, I now see this other field namespace populated. Now, if it's not populated at all, effectively you're by default in the default namespace. So if I were to do kubectl get pods and I don't have anything in the default namespace, which I apparently have a hello world aperture running in there, it would actually only show me what's in the namespace, the default namespace. So now that I've actually created a new context for the kube system namespace, let's switch over to that and see how that works. Config use context SE demo cube system. Now when I do my kubectl get pods, I'm actually only seeing those pods that are associated with the cube system namespace. And that means that if you were doing a bunch of work in a given namespace and you didn't want to keep typing -- namespace over and over and over again, you can actually just create a new context that associates with that particular namespace. And then all of your kubectl commands will by default be addressing only resources within that namespace, which is a definite time saver. So let's go back to the blog post and see what we're going to cover next. So that takes us up to the part where we talked about the different state files and the different and creating a specific context that associates with just a specific namespace. And I hope that makes sense to you folks. And any questions that you have, please enter them into the questions piece. And again, I'm happy to answer any questions that come up. The next piece I'm going to show you is one of the interesting ways that you can actually leverage the kube proxy mechanism to pull down a very important file called swagger.json. Now, the swagger.json file is effectively just the API contract that is present in your that is provided by Kubernetes that describes the entire API that is available to you, with the exception of some extensions. But this API is actually super useful, or the Swagger.json document is super useful because it allows you to understand what the pathing is and what particular constructs are hidden behind each individual different API group. One of the interesting things about the API that Kubernetes presents is that it is broken up by group. So when we think about things like role-based access control, role-based access control gives us the ability to create reasonable permissions around users trying to access particular components within the API that Kubernetes presents. But to really be able to leverage that role-based access control, we kind of have to understand in what group a particular object is or a particular idea is, such that we can actually give reasonable controls around it. So let's talk about like how to reason about what's in the API. And we'll do that by leveraging Kubeproxy first. So I'm going to look and see which cluster I'm in. So Kubectl get cluster info. I'm still pointed at the SE cluster we have internally here. So I'm going to try Kubectl proxy, and I'll just background it. And it tells me that it's starting to serve on 127.0.0.1.8001. Now, what I can do from the command line here is basically just pull that whole Swagger document down. Right. So I'll just do a curl command and point to where that path is. And that gives me the swagger.json, which is a huge JSON document that describes all of the things that are exposed in this API with descriptions and kinds, a lot of really good contextual information. And if you really want to get into the nuts and bolts of what is actually happening in the Kubernetes API, this document is the keys to the kingdom. You can look through the entire thing and understand pretty much everything that's happening in that API and how to authenticate to it. But for our purposes, I'm going to use another tool called JQ. And JQ is a lightweight JSON processor that can do comparisons and quite a bit more. And it's an incredibly powerful tool for manipulating JSON documents. So the first thing we're going to do is we're just going to pull the keys back because it's going to be a lot easier to kind of like understand what's actually happening within that Swagger JSON document if we just look at the keys rather than all of the information in the file. So since we have Swagger.json locally, I'm going to pipe the output of Swagger.json into JQ, and then I have a filter that's written here that allows me to just basically describe all of the paths and only pull the key values from that entire set of paths. And my output here gives me the ability to understand by group what particular objects are exposed. So if I wanted to create a policy, for example, that limited the ability to read secrets, then the object that or the group that I would want to limit there would be API v1, which in the construct of RBAC is actually called core v1, CORE/v1. And so if I wanted to create that policy, I could actually just understand that the secrets object that I'm actually trying to limit access to is under the core API group, and it's actually called secrets. If we move down here, we can see that there's another group called APIs in which there are other API groups like apps. We have the apps one, we have the authentication, we have authorization, we have auto-scaling. All of these different objects are actually exposed in the API within these different groups, like the batch group, the certificates group, the extensions group. And the extensions, for example, has deployments, which may be another piece that you'd want to limit. Now, I also want to show you that there is actually a web interface for all of this as well. So I'm going to go navigate to that 8001 piece. And this is actually also helpful because it lets you kind of navigate what's happening inside of that space kind of manually. So if I do API v1, I'm actually looking at all of the objects that are available within that API. And then from there, I could do things like namespaces, and it will actually describe the namespaces that are available within the running cluster. And so this is more of an interactive way of understanding what's actually happening within your cluster, leveraging those same API constructs directly. So it's as though I'm actually making a specific API call, and I want to see exactly what's going to happen inside of that space. So in the API v1 namespaces, Duffie Cooley demo, and then let's look at the pods that are inside of here. Right. So now I basically said, for the namespace Duffie Cooley demo, I want a list of all pods. This is something you can do with your own API. If you want to explore what's available and what information is known in the API about what's about your existing currently running cluster, this is a great way to kind of explore that API, especially if you're trying to write different integrations for things. So there's another command called Kubectl API versions, and this one is actually pretty interesting because it's contextual. Especially if I can type the whole word. So if I type Kubectl API versions, it will produce a similar output to what we saw before. And these are the groups that are available. Okay, so here's our core v1 group. Here's the storage group, the policy group, monitoring, the extensions, all of that stuff. Now what's interesting about this though is that this API versions output is based on RBAC. And because I'm an administrator of the cluster that we're looking at, I get to see all of the different groups. But if there were RBAC policies that limited my access so that I couldn't see like the batch group, for example, then that would not show up in the output of Kubectl API versions for me. So it's an interesting way of understanding context as a user, like what particular API mechanisms are exposed to you as a user and what can you explore. Now, I'm also going to spend some time on Kubectl Explain because I think that it's actually super powerful in understanding some of the more detailed stuff that's actually happening within this. And Kubectl Explain is going to pull back some of that information that was exposed in the API into kind of a more useful way. So if I do Kubectl Explain, it will actually list all the things that it's happy to explain. And these are all the different objects that you can actually dig into detail on. So in this example, I'm actually going to describe how to do or how to think about the liveness probe. And the liveness probe is a mechanism that is actually exposed by a deployment. And the liveness probe it gives the deployment the context to understand whether your application is continuing to be responsive. And why this is important? This is important because you want to be able to ensure that the application is in a live state before you start continuing to deliver traffic to it. So one of the important things about the liveness probe is it gives us the ability to understand from within the context of your application whether the application itself is healthy. And this is one of the ways that we can ask your question. We can ask your application whether it is healthy. So if I do Kubectl Explain, and then I can actually do the whole dot separation right into liveness probe exec. And I get back this document that describes exactly what liveness probe exec is. And according to this, what it's going to do is it's going to actually run inside of the container that you've described the liveness probe in. It's going to exec into it, and then run whatever command you've got inside of it. And if that command exits as a status of 0, then it's in a live and unhealthy state. And if it exits non-zero, then it's unhealthy. And one of the things I want to point out here is this construct here, because you can see that I've gone into the deploy object, I've gone into the spec object, I've gone into the template, spec containers, all the way down to the liveness probe, and then to the exec option of the liveness probe. But you can actually jump in at any part of that path and see what objects are available to you. And then when you want to understand more about any particular object, say for example, we want to understand more about the security context, I can actually just hit dot and paste that in there, and it will explain the security context to me. And so if what you're trying to do is understand some of the capabilities that are in that YAML file or in that API object that you create when you're getting ready to create a new deployment or any of these things, this gives you the ability to understand exactly what those capabilities are so that you can make best use of them. Pretty neat stuff. I really, really like Kubectl Explain. And at this point, if you have any questions, feel free to enter them in, and I'm happy to answer them or dig into more detail around any of these objects. I see one question that is there a way to use multiple config files like without all them merging into a single config file? So this is the question. So yes, there is. And the way that works, and actually in the future, I think there's actually work trying to make it so that by default, Kubectl will support that kind of a mechanism in which you provide a config directory, and then you put all of your configs into that, and it will just automatically merge all of that for you. I don't know exactly where that work is right now, but I know that it's ongoing. But the interesting thing here is that this object, right, the kubeconfig object, you can actually, I actually really like this mechanism for exactly that purpose, right? You can actually describe multiple configs contextually, and because it's an environment variable, you could actually have this referenced within your bash profile such that you just load them, or maybe write a little bash script that allows you to manipulate the ordering or add or remove things. And in fact, that's kind of, I've written a bash script to do exactly that. So if I do KC list, I can see all of the objects that are available to me, and then I can also add something to the stack. And then if I do my KC list, which again is just an alias for Kubectl context list, then I can actually see all the different contexts that are available to me. And this allows me to kind of make sure that I'm being very explicit about which configurations are in my I'm making available to myself pretty easily. Hope that answers your question. Any other questions that we have? So the next piece I'm going to talk about is some of the more advanced JQ stuff that we can do. And there's another blog post that's going up today that kind of talks about some of that structure. I'm going to stop sharing my screen for just a moment, and I'll be right back. All right. So this is a preview of the blog post that's actually going to go up today, and it's like the second part of this two-part Kubectl tips and tricks piece. And we talk about pipelines in this case. So there, Kubectl also exposes a way to do quite a bit of different options for. Kubectl exposes quite a lot of different capabilities as well. Like what we talked about so far is around things like being able to manipulate different contexts and different mechanisms for understanding like which cluster you're talking to or which particular namespace you're looking at. But in this next part of the series, we talk about some of the other capabilities that that things are available or things are capable of. So in this case, I'm actually going to leverage the Kubernetes API to pull information about all of the pods within a particular within all of the namespaces. And if we do run this command, we're going to get overrun by a lot of information. So I'm not going to run it on the screen because I just don't think it would be very useful to understand. But what I do want to expose is the idea of JSON path, which is a way to export information about a particular object, or about particular objects within the construct of your cluster. So let's run this command, which is a way of actually describing all of the pods in all namespaces sorted by a metadata object called creation timestamp. And we're going to output that into the JSON path expression model, and then we're going to use JSON path, which is just another model similar to JQ, but built into to Kubectl, so you don't have to have JQ installed on your machine to be able to do this stuff. And we're going to arrange across all of the objects that come back, and we're going to output the name of the pod and the time that it was created. So let's take a look at the output of that command. Now, what we can see is that we're up against the Minikube configuration right now, and we can see that the three different pods that are within all of the namespaces are the add-on manager, the DNS piece, and the dashboard, and the times that they were created, and it was able to sort it by time. Let's look at a more interesting output. So if I do KC, if I switch back to that other configuration in which I'm actually if I jump into the SE demo context, I can actually see all of the pods from all of the namespaces, again, sorted by date. And this one's a little more interesting because there's a lot more information, a lot more pods to actually parse on, right? So I have a bunch of stuff that was brought up when the cluster itself was instantiated, and that's why they're early in the process. And then I have a bunch of stuff that showed up later in the process, things like the simple web app and some of this tectonic stuff. It's kind of an interesting output. Now, what's actually happening here is if we look at the command again, we can see these things like .metadata creation timestamp, and it would probably be useful for me to show you like what I'm actually basing all of those fields on. Like, where do I actually even get the idea of metadata creation timestamp? So if I do kubectl get pod dash namespace, well, actually I can just be the default namespace. Let's say I want to get the hello world one. Dash o JSON kubectl get pods h4. So we'll just take one of the objects and produce the output from that. By default, all that's going to happen when you do a get pod is it will tell you whether that pod is in a running state. It'll give you some other information. If you do get pod-o wide, it will give you the information about where that pod is located and what the pod IP address is. But that -o option has a lot more capability. If you do output of JSON, you can actually see all of the different mechanisms that we can actually relate to. So in this case, what we were talking about was metadata name. So let's scroll up here for a minute until we get to the metadata section. And there is the beginning of the metadata context. And then down here we have name. So when we say .metadata.name, we're jumping into this object and we're grabbing this object, and that's where we get hello world, the name object. We can also see creation timestamp here, and again, it's just under the construct of metadata. But all of these are exposable to are exposed to you within the construct of JSON path. Right? You could actually sort by image name by doing spec.containers.image. You could sort by image, there's all of this construct, all of this stuff is available to you. And JSON path provides a lot of really great context for being able to do stuff like that. There is a Kubernetes IO JSON path support doc, which I highly recommend taking a look at because it gives you a lot of really great examples for running these same things. These particular examples that I'm covering now are ones that we wrote, but there are many more available to you in that JSON path support doc hosted at kubernetes.io. The next example of this is going to be the find Kubernetes pod by label selector and fetch the pod logs. Now this is one that's useful, and there are actually examples out there that actually allow you to do this kind of with like a little Go binary. But let's just run this example and see what happens. Didn't quite copy that. So in my case, I'm going to set the namespace to my demo environment. And I'm going to set the label to my simple web app. And then what I'm doing is basically just exporting these variables, namespace and label, and then using them within the construct of the query itself. And that didn't work out, so let's do kubectl get namespace demo. And this is where the kubectl command line really helps us out. I can do show labels. This will describe all the labels that are associated with all of the objects that I've created. So when I do kubectl get pods namespace show labels, here is the label set that is associated with this particular application. And I can use that label set to do things like describe a service, or in this case, pull back the objects that are associated with simple web app Duffie Cooley demo. So I'm going to do get pods -n namespace -l label. I'm going to output that to JSON path, range over the items to produce the metadata name. I'm going to pipe that to xargs and then kubectl ns logs and then the object. Apparently there aren't any logs to produce, but you can follow the logic of what I'm trying to do here. I can do the same example for doing port forward into things. So if I know that the object is actually listening on port 8080, I can mount the port forward piece directly locally as well. Now this one is interesting because in this case it's only going to produce the first object, and this is where again the JSON path allows us to identify a particular item in order. It doesn't have to be all of them. Now we talked about JQ already. JQ provides us a lot more configuration, a lot more capability than JSON path does in some cases. And so there are certain things that we have to do with JQ, like we wanted to move objects around in an API object or something like that. But let's take a look at the output of this one and kind of understand what we see. So in this one is where we're looking for high-level statistics kind of on a particular node. And so what we're doing is we're going to get all of the pods in all of the namespaces, and we're going to output it as a JSON document. We're going to pipe that to JQ, and then we have this filter that is basically allowing us to understand what all of the objects by node name are. And so we can see that for all of these objects, right, these are the actual nodes within my cluster, I can see that I have a pretty well-balanced cluster. So each of the nodes in my entire cluster are running approximately the same number of pods. So my scheduling algorithm is probably working okay so far. But this might be helpful to you if you're trying to understand, like, but am I seeing a bunch of small pods kind of being deployed to a particular object and it's just overrunning that object? It's another way of actually kind of thinking about those sorts of problems. Now the label query piece is actually probably one of the more powerful primitives that are available within Kubernetes, because we use that label query in pretty much everything. Let's look at the spec selector. Let's look at the deployment spec selector to kind of understand what that's actually doing. We're going to go back and kind of revisit the explain functionality for a moment and talk about like how this works. So within the construct of a deployment, in the spec part of it, you can actually describe the selector that will be used for pods. And what this allows us to do is it describes a label selector that is a label query over a set of resources. The results of match labels and match expressions are added. And so these objects are things that you can actually put into the label selector for a particular deployment and use them in the way that we're about to use them here. So if I do kubectl get nodes -- show labels, since I'm actually on AWS, I get a bunch of different labels kind of created for me automatically. And one of the ones that I'm actually interested in right now is in the node role. And there are a couple of different node roles that are available to nodes within the construct of a Kubernetes cluster. We have the idea of a node, which is often referred to as a worker, and we have the object, and they have the idea of a master, which is often referred to as the component in your Kubernetes cluster where all of the critical control plane objects are going to run. So your API servers, for example, would be associated with nodes that are in a node role master, but your application may be associated with a node that is actually just a worker node. So for my cluster, let's look at the two different types. Let's separate these nodes by type. If I were to do kubectl get node-l and then paste in node role Kubernetes IO master, then it will return the masters that I have. And we can see that these lists are very different. So in this case, I'm running 5 masters and 4 workers, which is really interesting. So we can see that that's actually how this cluster is arranged currently. Probably running some experiment on multiple masters just to see what's happening here. Now, we said we noticed this before. We can do a get nodes or get pods and do the show labels piece and understand what pod and what those labels are, so we can understand how to actually go about manipulating those labels or using or defining a service or even just trying to pull back information about a particular type of application. Now, what's interesting here in this output is that we can see that here are 5 instances of a simple application running, and the labels allow us to easily identify those objects. So if we do kubectl get pods -l app equals simple web app, I can see what the output is, and if I do anything not that, you can do the reverse. You can do a negative match in the same way that you did the other piece. Doesn't seem to be working for me right at the moment, but you can do a negative match and actually produce a list of apps that are actually not the match that you're looking for. So let's just try and do this in a simple way. We do all of the objects that include the word app in their label query, and then all of the objects that do not include the name app in their query, then I can actually see that output, right? So like the first output produces all of the applications in that namespace with app in their label set, and the second one produces nothing because there are no applications in this namespace that don't include app in their label set. Now, one of the interesting things here is the ability to understand like a service that describes a particular group of pods. And so I have a service that's been defined here. And we'll look at that service real quick. And up here at the top, we can see that the service is actually looking for applications that match a particular label query. So here's that selector that we looked at from the deployment example earlier. And I'm looking for anything that has app set to simple web app. Now this is one of the, again, the power of Kubernetes here, is the ability for us to describe to us. Let's do a describe here. If we describe the service, it's going to give us a list of healthy endpoints that match that label query that we've got. Right? So here's our selector, and our app is equal to simple web app, and here are the 5 pod IP addresses associated with that particular application. Well, what's interesting here is that it's not necessarily tied to the pod itself, only to the label set. So if I were to do get pods again in that same space, in that same namespace, these are actually the names of the pods themselves. And then my label set is actually is an abstraction, because if I were to roll this to a new version or change the object at all, then effectively I would get new names and new pods. But because the label set still matches, those new objects would be automatically put behind the service. And it's one of the interesting constructs within Kubernetes. And this label set object is used everywhere in Kubernetes. We do this with network security policies. We do this with pretty much everything. So we've gotten a list for each node. And another one that is actually useful sometimes when trying to diagnose things is to get the external IP address of objects. And so in this output, we can see that the objects that the masters that I have are actually part of a VPC that has a public IP address. And these are the public IP addresses of these particular objects. So now that I know that, I can actually connect to that object. And then lastly, we have an example of SSHing into nodes with Fabric. And Fabric is a pretty interesting tool that allows you to SSH into things and kind of like manipulate them. So if you want to explore that, I definitely recommend going and checking out a blog post by Brandon Phillips, which was brought up earlier in this month, or maybe it was last month. But that's another really great talk there, or really another great example of how to actually manipulate things on the node itself. So you want to insert a CA file, or you want to change the SSH keys, or anything else like that. That's another really great way of actually kind of doing configuration management across things that are meant to be immutable infrastructure. Another pattern for stuff like this is a daemon set pattern, in which you describe like a BusyBox node, or sorry, a BusyBox container, and then all of the work that you need to do. So for example, you want to insert an SSH key, you could use a daemon set pattern to effectively run one of those pods on every one of your nodes, mount in the SSH known or authorized keys file, and then populate it, maybe run the command to do the update SSHD keys, and everything would just work for you. So it's two different patterns for configuration management in this new immutable infrastructure model that we're all kind of operating under. I know that was a lot of information, and we have about 10 minutes left of the webinar. So if you have any questions or anything I can dig into further, please let me know. Outside of that, I think I've covered what we've got to talk about here. So, well, thank you very much for your time, and we'll see you next time. Thank you.